Good evening, students. So this session we are going to see a few problems from Ncert solved for you. Let us solve a few from exercise 4.1. I have kept the question ready. Matrix A, it's a 2 by 2 matrix having elements 1, 2 in row 1, 4, 2 in row 2. We are supposed to show modulus 2A or determinant 2A is equal to 4 times determinant A. So let us start with LHS. What is determinant of 2A? Before that, let me keep 2A ready, which means it is a scalar multiplying a matrix. So all elements in the matrix to be multiplied by 2. So which means 2 times of 1, 2, 4, 2, which is 2, 4, 8, 4. So what about determinant of 2A? So I need to write determinant symbol and the elements of 2A, that is 2, 4 in first row, 8, 4 in second row. Evaluate as per procedure. So leading diagonal product is 2 into 4 minus of 4 into 8. So 8 minus 32. So minus 24 is the value of determinant 2A. Let us see the RHS. 4 times determinant A. So it is 4 times of the determinant A, matrix A written in determinant form. So the elements are presented as it is and continue to evaluate, write the value of the determinant 1 into 2 minus of 2 times 4. So 4 into minus 6. The answer is minus 24. So we find LHS equal to RHS. So hence the result is proved. So that is a very simple demonstrative question for probably a short answer. Let us choose one more question from the same exercise 4.1. I am writing the very next question. If the matrix A, now it's a 3 by 3 matrix, 1, 0, 1 in row 1, 0, 1, 2 given in row 2, 0, 0, 4 in row 3. The question is, then show that determinant 3A is 27 of determinant A. So this is the statement. Mod of 3A or determinant 3A is 27 times determinant A. So let us proceed as in previous problem. We need to work out what is 3 times of the matrix A. So every element multiply by 3. So I am doing it already. So 3 times of 1, 3 times of 0, 3 times of 1. Again 3 times of 0, 3 times 1, 3 times 2, 6. Then 3 times 0, 3 times 0, 3 times 4, 12. And it is easy to evaluate. Yes, we can directly evaluate the answer. Instead of evaluating the method we followed in the previous session like A11, capital A11, etc., all that you can do in mind. So I am taking up row 1 procedure, expanding by row 1, 3 followed by capital A11, cofactor 1, 1. Cofactor 1, 1, that is the minor, that is 3, 6, 0, 12. We know the answer is 3 times 12, 36. And the other product is 0. and followed by A12 capital A12, of course the answer is 0. And when I write A13 capital A13, that is element 3 followed by the cofactor. When I write cofactor, we know row 1 and column 3 to be ignored, and what is remaining is 0, 3, 0, 0. The determinant value is 0. So the answer is 3 times 36, which is 108. So this is determinant 3a. I'm sorry, I made a directly I wrote determinant 3a. RHS, let us write 27 of determinant a only. 1, 0, 1, 0, 1 and 2, 0, 0, 4. This also you can write directly 27 times. Start evaluating using row 1. So it is 1 into the corresponding cofactor is obtained by the minor 1, 2, 0, 4. So the product is 4 only, and plus next element is anyway 0, and followed by 1 into third A13 into cofactor 1, 3 is 0 because of the products available there. So the answer is 27 times 4 only. Again you can see the answer is 108. So what happens essentially is, here what we discover in the case of 2 by 2, multiplying matrix A by 2 multiplies the determinant of A by 4, which is 2 squared. We observe here 4 is 2 squared. And same way, in the case of 3 by 3 matrix, when every element of A is multiplied by 3, the answer is 27 times. And what is 27? It is 3 power 3 of determinant A. So we find the determinant A multiplies by the multiplier squared, the scalar multiplier. The scalar multiplier in this case is 2, and the multiplier becomes 4. Similarly, if you choose scalar multiplier 3, the determinant gets multiplied by 3 power 3. Why 3 power 3? The order is 3 because it's a 3 by 3 matrix. So 3 power 3. So from these two as a conjecture, we are able to arrive at, when we multiply a matrix A with a scalar multiplier K, determinant A gets multiplied with the same scalar raised to power n, where n is the order. N may be 2, n may be 3. So depending on the order, the result is either squared of k or cube of k times mod A. So students can understand this easily. Let us proceed to the next question from Ncert I am choosing. Find the values of x. Let me write here. Find values of x given 2, 4, 5, 1 as determinant LHS. In RHS, it is 2x and 4 in row 1, 6 and x in row 2. There is one more question of this type. Again, find x. If the determinant in left hand side is 2, 3, 4, 5, and on RHS x3 to x5. So how do we go about? A similar question I want students to carefully observe the symbol. But for this symbol, okay, the students can directly start comparing. If this was a matrix, okay, a square bracket here also, then it is a question of comparing matrices. And by principle of equality of matrices, if two matrices are equal, then they are equal in all respects. Their orders are equal, corresponding elements are equal. So you will start comparing every element by element. Here in determinants, such comparison is not possible. This determinant, okay, has its own value. The RHS determinant has its own value, and only the value and value, they are equal, not the respective elements. So students should carefully keep this in mind. Evaluate the LHS determinant. 2 times of 1 minus 5 times 4. Continue opening the determinant in right side. 2x times x to x square, and subtract 6 times 4, 24. So let us find out 2x square. It is 24 minus 24 brought to the other side. So you get 26 minus 20. So I get 2x square is 6, followed by x squared is 3, or x is plus or minus of square root 3. So that is the answer for the question. Let us proceed to the other question here. Same way, we cannot compare the elements as such. We need to compare the estimated values of determinants on LHS and RHS. So it is 10 minus 12. It is 5x minus 6x. So negative 2 is negative x also, and the x happens to be 2. Alright. So this is just to explain or bring awareness in the minds of students that you cannot compare element wise, okay, and you need to compare the evaluated determinant value of left and right determinants. Thank you. In the next session, we will do the next exercise involving triangle area. Thank you.